Hello! Now we're going to continue practical lesson with 3D modeling. This lesson will be led for you by Senior Lecturer of the Department of Architecture and Design, Domana Inessa. The title of today's lesson is Modeling and Transforming Objects with Splines, Editing Splines, Modeling with spline modifiers to create the architectural object rotonda. The aims of today's practical work: create splines, use editable spline objects, use the lace modifier to modify objects, and modify shapes. Softmax has several basic 2D geometric shapes known as splines and extended splines. They are used to create 3D objects, 3D surfaces, and paths for lofting and creating animation. All splines and extended splines can be created dynamically by using the mouse or by entering the parameters in the keyboard Enter Rollout. In this lesson you will learn about splines and extended splines. A shape in Softmax is an object consists of one or more lines. Those lines, which can be 2D or 3D, are used to create components for other objects. Softmax provides two types of shape objects: splines and NURBS curves. Most of the default shapes in Softmax are splines in Softmax. Softmax provides 11 basic splines objects, 5 extended spline objects, and 2 types of NURBS curves. You can use these objects in the following ways: generate planar and 3D surfaces, paths and shapes for the loft components, generate extrusions, generate revolved surfaces, and define motion paths for animation. Spline and extended splines primitives. You can access the shape creation tools from the Create panel. Go to the Create panel and then click Shapes. A drop-down appears below the Shapes button with 3 entries: Splines, NURBS curve, and Extended splines. Table 1 summarizes the available tools. You can also access those tools from the Create menu. If you are using the Enhanced menu system, you can access shapes from the Objects menu. Creating line spline. A line spline is a free-form spline that is made up of multiple segments. To create a line, go to the Create panel, click Shapes, and then click Line button on the object type rollout. Notice that various rollouts appear in the Create panel. Choose the creation methods on the Creation method rollout. Click or drag in the viewport to create the first vertex. If you click, a corner vertex is created, otherwise a Bezier vertex will be created. Now click or drag additional points. To finish the creation method, do one of the following: either right-click to create an open spline, or click on the first vertex and then choose Yes from the spline dialog that appears. To create a line spline dynamically, click on the top viewport to specify the first vertex or the start point of the line. Now move the cursor to define the distance between the first and second vertex, and click on the viewport to create the second vertex. Again, move the cursor and click to create additional vertex. Next, right-click to end the command and open line spline will be created. To create a closed line spline, instead of right-clicking at the end, click on the first vertex. The spline message box will be displayed. Choose the Yes button. A closed line spline will be created. You can also create a line spline using another method. Click in the viewport to specify the first vertex and then move the cursor to define the distance between the first and second vertex. Now press and hold the left mouse button and drag the cursor to create additional vertex. A line spline with a Bezier vertex and smooth curve will be created. The Bezier vertex is controlled by 2 points on both endpoints, which help in modifying the curve of the line. While creating a line spline, if you click in the viewport to create additional vertex, they'll become corner vertex. But if you click and drag to create additional vertex, the curve between the vertex will be smooth and the vertex will be Bezier. Depending on the options selected from the drag type and initial type areas of the creation method rollout. Various rollouts used to create and modify a line we will discuss next. Rendering rollout. The options in this rollout are used to toggle the shape renderability in the viewports and rendered output. It is also used to specify the cross-section settings and apply coordinates. These options we'll discuss next. Enable in renderer. By default, the line spline created by you is not visible at the time of rendering. Select the Enable in renderer checkbox to render spline as 3D mesh. Enable in viewport. Select the Enable in viewport checkbox to make the line visible as 3D mesh in the viewport. The Use Viewport Settings checkbox is used to set different rendering parameters and display the mesh generated in the viewport. It is activated only when the Enable in Viewport checkbox is selected. On selecting in the Use Viewport Setting checkbox, the Viewport Radio button will be activated. Select this radio button and modify the parameters such as thickness and size in the respective spinners. The line will be displayed as a 3D mesh in the viewport according to the parameters you set. Viewport. This radio button will be activated only if the Use Viewport Settings and Enable in Viewport checkboxes are selected. It is used to specify the dimension and shape of the line in the viewport using the radial or rectangle radio button respectively. Renderer. This radio button is used to specify the dimension and shape of the line on rendering, using the radial or rectangle radio button. Note that you can view the modifications in the line and rendering only if the Enable in Renderer checkbox is selected. Radial. This radio button is used to display Radial. This radio button is used to display the shape with a circular cross-section. The thickness spinner is used to set the thickness of the line. Similarly, the side spinner is used to set the number of faces along with the cross-section of the line. The value in the angle spinner is used to set the position of the cross-section of the line by rotating it. Rectangular. This radio button is used to display the shape as rectangular mesh. You can set the length and width of the line in the length and width spinners, respectively. The angle spinner is used to set the position of the cross-section of the line by rotating it. The aspect spinner is used to set the constant ratio of width and length. Choose the lock icon on the right side of the aspect spinner to lock the constant ratio of width to length. Now, if you set the value in the length or the width spinner, the values will be set in both the spinners simultaneously. Orthosmooth. By default, the Orthosmooth checkbox is selected. It is used to smoothen the angle between the line segments depending upon the values at the threshold spinner. The value in the threshold spinner is used to set the threshold angle in degrees. Interpolation rollout. The options in the interpolation rollout are used to define how a line will be created. The number of segments between each vertex on the line are called steps. The value in the steps spinner defines the number of steps between each vertex on the line. Larger the value in the step spinner, smoother will be the line. By default, the Optimize checkbox is selected, which helps you to remove the unwanted steps on the straight line, and you can set the number of steps by entering the value in the step spinner. If you select the Adaptive checkbox, it will automatically set the number of steps to create a smooth line. The Optimize checkbox and the Steps spinner will also become inactive. Note that the options in the name and color rendering and interpolation rollouts are same for all splines and extended splines in Autodesk Max. Creation method rollout. The options in this rollout are used while creating a line dynamically. The two areas in this rollout are discussed next. Initial type area. The options in this area are used to define the type of vertex when you click on the viewport to create it. By default, the corner radio button is selected. As a result, a sharp point is created and the line between the two corners vertex becomes straight. You can select the Smooth radio button to create a smooth and non-adjustable curve between the two vertices. Drag type area. The options in this area are used to define the type of vertex of the spline while dragging the cursor in the viewport. By default, the Bezier radio button is selected, which creates a smooth adjustable curve with Bezier vertex. You can modify the shape of the curve using the two control points of this Bezier vertex. The corner and smooth radio buttons perform the same functions as described in the initial type area. Keyboard entry rollout. The options in this rollout are used to create a line by entering the parameters in the keyboard entry rollout. The X, Y, and Z spinners are used to specify the position of the first vertex of the line along the axis of the home grid or a grid object. The Add Point button is used to create the vertex at the location specified in the X, Y, and Z coordinates in the viewport. The Close button is used to create a closed line, and the Finish button is used to create an open line. Note that the keyboard entry rollout for all splines and extended splines is used to create the corresponding spline by entering the parameters using the keyboard. The method of creating all splines is same as discussed above, with the only difference in the type and number of parameters entered for various splines and extended splines. Rectangle spline. It creates square or rectangular splines. If you want to create a square spline, press and hold Ctrl while dragging in a viewport. To create a rectangular spline, first select a creation method and then drag the mouse pointer in a viewport to create a rectangle. Circle spline. It allows you to create close circular splines made up of 4 vertices. To create a circular spline, first select the creation method and then drag the mouse pointer in a viewport to draw a circle. Ellipse spline. You can use it to create circular or elliptical splines. If you want to create a circular spline, press and hold Ctrl while dragging in the viewport. To create an elliptical spline, first select the creation method and then drag the mouse pointer in the viewport to draw the ellipse. Arc spline. You can use the arc spline to create open and closed partial circles made up of 4 vertices. The arc spline provides 2 methods for creating arcs: end, middle, and center, end. To create an arc using the end and middle method, make sure end and middle is selected in the creation method, and then drag in the viewport to define the 2 ends of the arc. Now release the mouse button. Move the mouse pointer up or down to specify the 3rd point between the 2 endpoints. To create an arc using the center end method, make sure the center end is selected in the creation method rollout, and then click to set the radial center of the arc. Drag the mouse pointer and click to specify the start point of the arc. Now move the mouse and click to specify the other end of the arc. Donut spline. It creates the donut-like shape of 2 concentric circles. To create a donut spline, first select a creation method, drag the mouse pointer and then release the mouse button to define the first circle of the donut. Move the mouse pointer and then click to define the second concentric donut circle. N-gon spline. It creates flat-sided splines with n number of sides and vertices. To create an n-gon spline, select a creation method and then drag the mouse pointer in a viewport. Release the mouse button to create the spline. Star spline. It creates closed star-shaped spline with any number of points. To create star spline, drag the mouse pointer and then release the mouse button to define the first radius. Move the mouse pointer and then click to define the second radius. The second radius can be less, equal, or greater than the first radius depending on how you move the mouse pointer. Text spline. It creates splines in the shape of the text. The text can be created using any Windows font, both TrueType and OpenType, installed on your system, as well using the Type 1 PostScript font installed in the Fonts folder of the Sourcemax installation folder. To create text, enter the text in the text box and then either click in a viewport to place the text or drag the mouse pointer to place the text in a viewport and then release the mouse button. Helix spline. It creates spiral-like shapes. To create a helix spline, click and drag the mouse pointer to set the starting point as well as its starting radius, center creation method, or diameter, edge creation method. Now move the mouse pointer vertically and then click to define the height. Move the mouse pointer and then click to define the end radius. X-spline. It creates an X-shaped spline. To create an X-spline, drag the mouse pointer vertically to define the initial dimension of the egg. Now drag horizontally to change the orientation angle of the egg. Release the mouse button to complete the creation process. Section spline. The section spline is a special type of spline that lets you generate splines based on a cross-sectional slice through a geometry object. To create a section shape, click Section from the Object Type rollout and then drag a section plane in the viewport. Now place and orient the plane in the viewport using transformation tools. Notice a yellow line is displayed where the section intersects the mesh. Now on the Section Parameters rollout of the Command Panel, click Create Shape. In the Name Section Shape dialog that appears, type the name for the spline and then click OK. Now select the shape in the Scene Explorer and then move it away using the Move tool. The length and width controls in the Section Size rollout control the size of the section rectangle. Editing splines. You can convert a spline object to an editable spline object. The editable spline object allows you to create complex shapes using the 3 sub-objects levels that this object provides. It is vertex, spline, and segment. The vertex defines points and curved tangents. The segments connects vertex. The splines are made up of one or more connected segments. You can convert a spline object to the editable spline object by using one of the following methods. First, select a spline in a viewport and then go to the Modify panel. Next, right mouse click on the spline entry in the stack display and then choose Convert to Editable Spline from the pop-up menu displayed. Second, select a spline in a viewport and then right mouse button click. Choose Transform in lower right quadrant, Convert to Editable Spline. 3. Select a spline in a viewport and then apply the Edit Spline modifier to it. If you will use the Edit Spline modifier to convert a spline to the editable spline object, however, when you convert a spline to the editable spline object, you lose the creation parameters of the spline. By default, the line spline to an editable spline object because it has no dimensions parameters. Therefore, you don't need to convert a line spline to the editable spline object. A compound shape made up of 2 or more splines is automatically an editable spline object. When you convert spline to editable spline, you can define vertex points and curve tangents for a spline object. To select a vertex type, select vertex or vertex and then right mouse button click. Now you can choose the required level from the upper left quadrant of the quad menu. For example, corner. Corner type creates non-adjustable vertex that generates sharp corners. The vertex types Bezier creates adjustable vertex with locked continuous tangents handles that products a smooth curve. The curve is determined by the direction and magnitude of the tangent handles. You can adjust the tangent handles using the Select and Move and Select and Rotate tools. Bezier corner type vertex creates adjustable vertex with discontinuous tangents handles that produce a sharp corner. The curvature is determined by the direction and magnitude of the tangent handles. You can adjust the tangent handles using the Select and Move and Select and Rotate tools. The vertex type Smooth. It creates non-adjustable vertex that generates smooth continuous curves. The curvature is determined by spacing between the adjacent vertex. Segment level. A segment is a part of spline between 2 vertices of the spline. You can select one or more segments by activating the segment sub-object level. Once selected, you can transform them using the transformation tools. Most of the controls available for segments are similar to those discussed in the vertex level section. The other controls available at the segment sub-object level are discussed next. Geometry rollout. Divide. Subdivide the selected segments by editing a number of vertices that are specified by using the spinner available on the right of this spinner. To subdivide a segment, select segment or segments of the spline. Now specify the number of vertices and then click Divide. The distance between the vertices is dependent on the curvature of the segment. You can delete the selected segments from the spline. It lets you detach copy selected segment from the spline. To detach segments or segment, select them and then click Detach. In the Detach dialog, type name in the Detach as text box and then click OK. The segment will be detached from the spline and new shape will be created. In the table, summarize options of Detach options. Changing segment properties. You can switch between the curve or line type for the selected segments. To change the type, select segments and then right mouse button click. Now choose line or curve from the upper left quadrant of the quad menu. On the example you can see a segment converted from the curve type to line type. Spline level. The spline sub-object level allows you to select single spline or multiple splines in a single object. Once selected, you can transform them using the transformation tools. Most of the controls available for segments are similar to those discussed in the vertex level and segment level sections. The other controls available at the segment sub-object level we will discuss next. Geometry rollout. Connect copy works when you make a clone of the spline using Shift. You must turn on Connect Copy before the cloning operation. When on, Sourcemax creates a new spline sub-object that connects the vertex of the original and cloned object. Threshold. Define the distance then the soft selection used during the Connect Copy operation. Outline. Makes a copy of the spline. The copy offsets in all directions specified by the spinner on the right of outline. You can also create an outline interactively by using the mouse. To create an outline, select one or more splines and then click Outline. Now drag a spline to create outline. When center is on, the original spline and its outline moves away from an invisible center line by the distance specified by dragging operation or by value specified for the spinner on the right of outline. Boolean combines two splines. It alters the first spline you select and deletes the other one. There are three types of Boolean operations available. In table, summarize this operation. Two Boolean splines. Make sure both splines are part of a single spline object. Use Attach to attach them. Select a spline and then click Union, Subtraction or Intersection. Now click Boolean. Hover the mouse pointer on the second spline and then click when shape of cursor changes to complete the operation. Mirror allows you to mirror splines horizontally, vertically, and diagonally. To mirror a spline, ensure it is selected and then click Mirror horizontally, Mirror vertically, or Mirror both. Next, click Mirror to complete the operation. If copy is on, Sourcemax creates a mirror copy of the spline. When About Pivot is on, Sourcemax mirrors the spline along its geometric center, otherwise mirrors along the spline object's pivot point. Trim allows you to clear the overlapping segments in a shape. The two splines must overlap each other and they should be part of the same spline object. To trim a spline, select the spline that will be used to trim the targeted spline. Click Trim and hover the cursor of the spline that you want to trim, and then click when the shape of the cursor changes. As we discussed earlier in the modifier section, we have covered their application to standard primitives. Modifiers also apply to splines. We'll take a closer look at applying modifiers to splines in the next section. And in this lesson, we will look at one of the modifiers, which is called lace. You can use the lace modifier to rotate a spline shape or NURBS curve about a specified axis. The lace modifier is a shape modifier and is used to create 3D objects by rotating shapes about their axis. The direction of the axis of revolution depends on the pivot point of the shape. To apply the lace modifier on a shape, create a shape in the front viewport and select it. Choose the Modify tab in the Command panel, and then select Object Space Modifiers, Lace, from the Modifier List drop-down list. The 2D shape will be converted into a 3D object, and it will be displayed in the viewports. When you apply the lace modifier on a shape, it will be displayed in the modifier stack. The parameters rollout will be displayed below the modifier stack. In the parameters rollout of the modifier, ensure that degrees is set to 360 to create a full 360 degrees lace. Specify the segments for the lace object using the segment control. The task for this practical lesson will be the creation of architectural object rotunda. Take a closer look at the appearance of the rotunda and analyze. Try to simulate a copy for rotunda model. We see that with help of spline modeling and applying a modifier lace, you can successfully create this architectural object. This concludes today's practice session, and let's take a look at what we learned in today's lesson. We learned how to create splines, introduced how to convert spline shapes in editable splines, use the lace modifier to modify objects, and we got a task of today's practical lesson, which was the creation of architectural model Rotunda. See you in next lesson.